we can use three different locations of the memory, and the location is 154 because this is linked list, so the data can be stored in any of the memory location, right? And in a linked list, do we always need to store them in alphabetical order or in ascending or descending order?
No,
It's
madam.
not mandatory. The list can be sorted or the list can be unsorted. Okay, so suppose in the first memory location in 1, or how we'll get to know that this position 1, it will contain the first data item. It depends on the value of pointer. So the pointer name can be head, it can be top, it can be start. Okay, so if head equals to 1, that means this is our first memory location. It will store the first data. So 10 is the first data item, it will be stored here. Okay, and which one is the second data item? It can be 20 or it can be 13. Suppose 20 is the second data item and it's stored in which memory location? In memory location 5. So here we can store 20, and the third one is stored in location 4 or position 4. So its address will be 4, and the data of this memory location is 13, right? And if 13 is the last data element, we can write 0. So in this single linked list, we can see that after we have to access 10, after processing or after traversing these data elements, now we can access the second data element 20, after that 30. But when we are accessing the second node, at that time we cannot again go back to the previous node because it is single linked list. Here the navigation is forwarded only. So what we need to do if we want to access the previous node, we need another pointer variable, right? If we want to access the previous node, then we need another pointer variable which is called, we can call it previous. Hello?
Yes, ma'am.
Yeah, so in double linked list, what we can do, we can access the previous data elements. So here we can see that there are total 3 data elements, 10, 20, 13, and we know which one is the next node of these nodes. Okay, so after processing 20, now if we want to go back, we know that the previous data item of 20 is 10 and it's stored in which location? 1. So here we can use another pointer and the value will be 1. In the same way, suppose we are accessing the data element 13. So which one is the previous node of 13?
Five.
Obviously 20, right? 20 is the previous node or data of 13 and its position is 5. So here we can write 5. Okay, and 10 is the first data element of this list. That's why here we can write 0. So the main difference of single linked list and double linked list is, in single linked list we cannot visit the previous nodes, but in double linked list we can access both the previous nodes as well as the next node. Okay, so for single linked list, what is the memory representation of single linked list? We just need two one-dimensional arrays, right? So one array will be used for storing the data and another for storing the address of the next data element. And for doubly linked list, we need one more array for storing the address of previous data element. Okay, so suppose we want to store some data elements such as 15, 20, 25, 35. There are 4 data elements which will be inserted in a doubly linked list, and this list has 8 available spaces. 4, 5, 6, 8. Okay, so the positions are 1, 2, 3, 4, 5, 6, 7, 8, and we'll use this array for storing the address of previous data element, and this array will be used for storing the data, and the third one will be stored here. We will store the address of next data element. So these are the name of the array. This previous, data, next, these are the name of the array. Okay, so how many data elements we have? 4 data elements: 15, 20, 25, 35. So suppose the value of head is 4 or 3. If we want to store them in ascending order, that means the first data item 15 will be stored where? In position 3. So here we can insert 15. After that, the next data item will be 20, right? If the list is, what should I say? If it is a sorted list, if we want to store the data in ascending order, that means after 15, we have to insert 20, then 25, and lastly 35,
There you are.
right? So suppose 20 is stored here in this position, and then 25, and this is 35. Now we can create the link. The first data item 15 is stored in location or position 3, and the next item, next data is 20, and its position is 5. So here in this next array, we will write 5, right? And after that, what is the third? Which one is the third data item? 25, and its position is 1. So in this position, in this location, we will write 1. The value of next 5 is 1. So 25 is the next data of 20. After that, here the value will be 7. Because after inserting 25, we can insert 35 when its position is 7. And which one is the last element of this list? 35. So that's why we'll write 0 here. So these are the value of, or these are the address of next data elements. So here in the same way, we can store all the address of previous data elements. Suppose 35 is the last data elements of this list, and before 35 we store which data item? 25, and its position is 1. So the previous value of 35 will be 1, right? And what about 25? Before 25 we stored 20, and its position is 5. So here in this array we'll write 25, right? And the previous data item of 20 is 15, and it's stored in location 3. So here the value will be 3, and 15 was the first data element, so there is no previous node of 15. So this is our linked list. Is that clear?
Yes, ma'am.
Yes, ma'am.
Okay. Yes. So now for performing some operations such as insertion, deletion, we need to maintain some available spaces, right? And here there are total 4 available spaces. So suppose 8 is the first available space. After that, the next available space is 2, and then 6. Okay. The first one is 8. And the next available space is 2, then 6, and then 4.
This is the problem why when available space why at first two it's understandable.
I'm just assuming it. Okay, suppose the available value is not given in the question paper, so you can just create the sequence by your own. It depends on you. Is that okay? It depends on you. Here I'm just assuming that my first available space is 2. I just want to insert the first data item in this position, and then you can take any other places. You can take any other available spaces, second available space, third available space. It's your choice. Is that clear?
Okay.
So suppose in this list we have total how many spaces? Total 8 spaces, and 4 locations are filled with data. So we have how many empty spaces or location? 4.
4,
right? So now we can, so suppose our first available space is 8. If you want, you can consider the first available space as 2 or 4 or 6. It depends on you. Okay. So the first one is 8. After that 2, and then 6. Where is 6? Here. Then 4, and the last. This is the last available space.
Yes.
So now we want to insert some data. Okay. Suppose we want to insert 10 at the beginning. So what is the operation name? Insertion, and that insertion will be done where? In the first place of the list. So the operation name is insert 10 at the beginning. So how many information we need to gather before starting this operation? At first, we need to know which one or from where we have to start, what is the value of this head pointer, and which one is the first available space, right? So in this list, first available space is 8. So we're going to insert the new data item where? In position 8. So our inserted position will be 8. Inserted position equals to avail and avail equals to 8. Okay. Now we can insert the data item where? Insert data at avail. The value of avail is 8. So here we insert 10. The operation is insert 10 at the beginning. So we'll insert the new data 10 in the first available space and it's 8. So here we can insert 10. So after inserting the data item, now look at the list. How many things will be changed? If we are inserting 10 at the beginning, now 15 cannot be the first data item. 10 will become the first data item. So we need to change the value of this head pointer. And another thing here, the previous node of 15 cannot be 0 because now 10 is the first data element. So before 15, another item you can find that is 10. Is that clear? How many things we have to change?
Yes, ma'am.
Okay, so after inserting the data in first available space, now we can change the value of avail. What will be the new value of avail? Avail equals to next avail. Okay, so here from this list we can see that avail equals to 8 and this is the array next, and next 8 equals to 2. So the new available space will be 2. Okay, so now the new value of avail is 2. Okay, so now after that we have to change the value of next 8. When this space was empty at that time, the next pointer value was 2, but after inserting 10 in this list, now 15 will become the second data item of 10. That's why we should write 3 here
3.
because 3 is the position of 15. So we can write next IP equals to head. Okay, so the next step of the algorithm will be next IP equals to head. And what is the value of inserted position? The value of inserted position was 8 and head equals to 3. Now look at the list. Next 8 equals to 3. That means now 15 is the next data item of 10. Is that clear?
Yes, ma'am.
Okay. And another thing now we have to change, that is the value of previous head. Here head equals to 3, right? So we need to change the value of this pointer. So which address should be stored here? The data is 15 and initially 15 was the first data item of this list. That's why its previous value was 0. But now there is a data element 10 before 15. So here in this position we should write the address of 10 which is 8, right? So what will be the step here in this algorithm? We can write previous head equals to inserted position, isn't it? Previous head equals to inserted position. So here head equals to 3, so previous 3 equals to 8. After inserting the data item, now it will become the first data item of the list and it will make the previous first data item second, right? Now 15 will become the second data item. That's why its previous value will be 8. And after that, now the value of head will be changed. We can write head equals to inserted position. So what is the new value of head? The new value of head is 8.
Yes, ma'am.
That means 10 is the now first data item of this list. So what was the operation? Operation was insert 10 at the beginning of the list. So if we want to insert a data item at the beginning, at first find out the available space, then set that data item in that available space, then change the available space. After that, change the next pointer value of the inserted position of the new data item, and then change the previous value of 15 or the previous first data item. I hope it's
Ma'am,
clear to you now. Yeah.
ma'am, had you called 10 or 8, ma'am? This
Sorry,
is the
sorry, sorry.
data.
Yeah. Thank you so much. That is 8.
Yes, ma'am.
Thank you. So that is the operation insertion. Insertion at the beginning. But still, if you have feel confusion in it, you can tell me. No confusion. Okay, so now we can insert another data item at the middle of the list, or at first we can insert it at the end. So now insert 40 at the end. What is the operation name? Insert 40 at the end. So for inserting another item, we need to write the new list first. Okay, so this is our new list after inserting the data item 10. So how many data items will stored here?
1, 2,
How
3.
many data items this list
8.
has?
8,
5
ma'am.
data items.
Ma'am, 5.
So 8 available, 8 spaces. And these are the data. 10, after that 15, then 20, 25, and then 35. Okay, and we can write this is data next, and this is the array previous.
Yes.
So the first data item is 10, right? After that 15,
3,
and then 20,
5, 1.
right?
Yes, ma'am.
Then 25, after that 35, and 35 is the last data element.
0.
So can you fill up this array previous? Just start with the last data item. The last data item is 35. So what will be the value of its previous pointer?
1.
Ma'am, 1, ma'am.
Very good, 1. And
Yes,
then
ma'am.
for 25, the previous
And
value will
then
be 5. Very good.
5,
And then
5,
for
ma'am.
20,
3.
no, for
Ma'am,
20
3,
it will
ma'am.
be 3.
3, ma'am.
15 is the previous value of 20.
3,
After
3,
that,
ma'am.
yeah, 3.
7.
Then,
Yeah.
very good.
S-
Why
8, ma'am.
7?
8.
No.
8.
80.
8, ma'am.
Yes, 8.
8.
Oh, yes, ma'am. 8.
And 10 is the first data item, so its previous
0.
value will be 0.
0.
Okay, so now the operation is insert the data item 40 where at the end of the list. End of the list, that means now we need another pointer which is called tail, isn't it? So for this new list, now tell me what is the value of head or start, then FA, and what is the value of tail?
Head is 8.
It's the first data item, right? So that's why head equals to 8. And now the first available space is 2.
Ma'am, 2, ma'am.
2, available equals to 2. And 35 is the last element of this list. That's why tail equals to
7.
7. Okay. So if we want to insert 40, our first job will be to find out the first available space. Here available equals to 2, so our inserted position will be 2. Okay. Now another thing is, if we want to insert a data item where at the end, how many things we have to change? In this list, the last data item is 35. That's why its next pointer value is 0. But after inserting 40, its value will be changed. 40 is going to be the next data item of 35. That's why it should indicate,
2,
or
ma'am.
we should write the
2.
address of 40 here, and another changes will be here. After inserting 40, its next pointer value should be 0. Isn't it? So if inserted position is 2, at first we can insert the data item. So insert data at the first available space, that is data 2 equals to 40. So where will insert it? In this position. So it's 40. After that, change the value of avail. Now the new value of avail will be avail equals to next avail. Here avail equals to 2, so next 2 equals to, okay, we need to write. Now which one is the first available space? 2, after that 6, and then 4, right? So can you just fill up this array? Now the last available space is 4, and which one is the previous available space is 4? 6. So here we can write 6, and then the previous available space of 6 is 2. So here we can write 2, and the value of previous will be 0. Okay, so after inserting 40 in the available space 2, now we have to find out the new value of avail. Just look at the list and then tell me what will be the new value of avail.
Ma'am, this is 6.
Very good, 6, because avail equals to next avail, and here avail equals to 2, so next 2 equals to 6. So here the new value of avail will be 6.
Yes,
Okay,
ma'am.
is that clear?
Yes, ma'am.
Okay, now the thing is, how many changes we have to make now? Its value will be changed here. Now it's not the available space, so we have to change the value of previous 2. So how we'll change it? 2 is our inserted position, and before 40 we have another data item 35. So here in this place we have to write the address of 35.
7.
7, ma'am.
So the step will be previous IP equals to tail, right? The step will be previous, IP equals to tail. So what is the value of IP? The value of IP is 2, and tail equals to 7. Tail equals to 7. So in this position we'll write 7, which means that 35 is the previous data of 40. Okay, and now its next pointer value should be changed. 40 is the last data of the list, so its next pointer value should be 0. So we can write next IP equals to 0. Clear? Next IP equals to 0, that means now 40 is the last data element of this list. Okay, so is there any other thing we have to change? Just look at the list. We just changed the previous address, previous value, and next value of the new node 40, and now we have to change the next value of 35.
Yes,
Next
ma'am.
value of 35. So we can
35.
write next
2,
tail
ma'am.
equals to inserted position. What will
Position.
be the step?
2.
Next tail equals to IP. So what is the value of tail? Tail equals to 7. So next 7 equals to 2. So here you can write 2. So now look at this new list. The first value of the list is, first data is 10. After that 15, and then 20, then 25, 35, and the last data item is 40, and we wanted to insert 40 where? In the last position of the list. And how we can say that 40 is the last data element? Because its next pointer value is 0.
Null. Yes, ma'am.
Right? And 35, which was the previously it was the last data item of the list, now we have made it the previous data item of 40. So is that clear?
Yes, ma'am.
Okay.
Yes,
Now the
ma'am.
next one, the next insertion operation, where we'll insert the data item between two data. Okay, so Let me create the new list first. So after inserting 40, now we have how many data elements in the list? Total 6 data elements. Okay. And this is the array previous. This is the array next, sorry, data and next, right? And these are the position. Okay, and our first data item is stored where? In position 8. So 10, after that 15, and 20, 25, then 35. The last data is 40. Okay, so we can set the pointer values here. So after 10, it will be 3, and 5, 1, 7, 2, 0. Right? And what about the previous array? The last data item is 40, so 0. Sorry. The last data item is 40, but its previous data is 35 and its position 7. And what is the previous pointer value of 35?
7.
For 35, it will be 1,
25.
because 25 is the previous data of 35, and after that 5, and then 3, 8. And the first data item is 10. Okay? So in this list, what is the value of head, tail, and avid?
Head equals to 8.
Head equals to 8, okay, and tail equals to 2, and avid equals to 6,
Yes.
right? So here we have only 2 available spaces, that is 6, and after that 4. And now we'll insert a data item where between two data elements. So suppose insert 30 between 25 and 35. Between 25 and 35. Okay. So if we want to insert a data item in the middle of some data elements, how many things we have to find out? At first, we need to know the available space, right? And then the previous value and the next value of that data item. In this list, we want to insert 30 between 25 and 35. So 25 will be the previous data item of 30, and 35 will be the next data item of the 30. Isn't it? So in which position 25 and 35 are stored? At first, we need to know the position of previous data element, and here the previous data element of 30 is 25. And what is the position of 25? What is the position of 25? 1. Just look at the list again. Here we want to insert data 30 between 25 and 35. So the sequence will be 25, then 30, then 35. So the previous data of 30 is 25 and it's stored in position 1. That's why previous position equals to 1. What about the next position? Here next position equals to
7.
next previous position. Look at this. Next position equals to previous position. Here, this is our next array, and the previous position is 1. So next one equals to 7. Right? Which one will be the next element of 30? 35, and it's stored in 7. So if we write next position equals to next previous position, and here previous position equals to 1. So from the next array, we know that next 1 equals to 7. So 7 is the next position of 30. So the new data item 30 will be stored between 25 and 35, and the position of 25 is 1, the position of 35 is 7. So which is the first available space? The first available space is 6, so that is our inserted position. Then insert data where at the first available space. So data 6 equals to 30. Is that clear? So in this position we'll insert 30. Now 6 is not an available space, so change the value of avail. The new value of avail will be avail equals to next avail. So what will be the new value of avail? 4. Here avail equals to 6 and next 6 equals to 4. So this is the new value of the pointer avail. Is that clear? Okay, so after that now how many things will be changed? Obviously we need to change the previous value, previous pointer value and next pointer value of the inserted data item. We just inserted which data item? 30, so its next pointer value and previous value should be changed. 30 is inserted between 25 and 35, so that's why the previous value of 30 will be 1 because 25 is stored in 1, and the next pointer value of 30 will be 7 because 35 is stored in 7. In this list we inserted item 30 where? Between 25 and 35. This is the data item 30, right? So its next pointer field and the previous pointer field should be changed. So how we can change it? Can we just write next IP, here IP equals to 6, next IP equals to NP. Can you write it? Next IP equals to NP. So what is the value of IP? What is the value of IP?
6, ma'am.
6.
6. Yes. So next 6 equals to the value of NP is 7. So here we can write 7. That means the next node of 30 is 35. Okay. So now we'll change the value of this pointer field. Which one is the previous data item of 30? The previous data of 30 is 25 and it's stored in position 1. So we can write previous IP equals to PP. Previous inserted position equals to what should I write here? Previous inserted position equals to
PP.
PP, very good. Sorry. So here IP equals to 6 and its previous value will be the value of PP and PP equals to 1. So here we can write 1. Clear?
Yes, ma'am.
Is that clear? Okay, so which one will be our next step? Which value will be changed now? Look at the list when we didn't insert, when 30 was not here at that time, 25 was the previous data of 35 and 35 was the next data of 25. That means we need to change 2 more values. When 30 was not here, was not in that list at that time, 25 was the previous data item of 35, but now 30 will be the previous data item of 35. So this value will be changed. What is the previous value of 35?
6.
Now 30. So here the value will be 6. The value will be 6, right? And another change you have to make, that is the data item 25. Now the next data item of 25 is not 35. The next data item of 25 is 30 and its
6.
position is 6. Clear?
Yes, ma'am.
Okay, so that is how, I mean, this is the process of inserting the data item between 2 data elements. So how many things we have to change here? At first, we'll change the value of avail, okay? And then change the previous pointer value and the next pointer value of the new data item. Then change the next value of 25 or the previous position, then change the previous value of the next position. I hope it's clear to you now.
Ma'am, should we change the new avail?
Yeah, here we changed it. The new value of avail is 4.
Okay, ma'am.
But in this process here, we don't need to change the value of head, or we don't need to change the value of tail, because we didn't insert the data item in the beginning or in the end. Clear? So in this chapter, in linked list, we just need to cover one more topic, that is the circular list. Okay? So another type of linked list we can use, and that is called circular list. So what is the difference between the previous, the single linked list, double linked list, and circular linked list? In single linked list, how many parts a node can have? Only 2 parts, right?
Yes.
One is data field, another is pointer field. And what about doubly linked list? In doubly linked list, there were 3 nodes, 3 fields. One is previous field, then data, and another is next, right? And in single linked list, we know that after processing a data, we can process its next data. We cannot process the previous data, right? But here, we can process the previous data item as well as the next data item in a doubly linked list. So what is this a circular linked list? Suppose we have 3 data items. One is A, another is B, and the third data is C. So this representation is the representation of a single linked list, right? And if the address of A, B, C is 1, 2, 3 respectively, and if the value of pointer is 1, if the value of start pointer is 1, so A will be the first data of the list, after that B, and the third data is C, right? So here from this representation, at first we can process the first data item A, after that B, and then C, and that is the end of the traversing process. After processing all these 3 data items, how many times? Only once. We have to stop the process here. What about doubly linked list? In doubly linked list, we can process the previous data item also, right? So what about the circular linked list? In circular linked list, we will not use one more field here, but we can create a relationship between the last data item and the first data item. That means the next pointer field of the last data item will hold the address of the first data item. That's why it's called circular linked list. That means here the traversion, we can process the data items. How? Look at this. We have created a ring here, right? That means after processing A, we can process B, after that C, then again A. In circular linked list, there will be always a connection between the last node and the previous node. So the last node will always contain the address of the first node. So here the traversion will be like this: A, after that B, and then C, then again A. But that doesn't mean that we can again process the second data item B. In circular linked list, the first node will be processed twice, because we just created a relationship, we just created a link between the last node and the first node, and that is circular list. Circular linked list. Clear?
No null value.
No null value. Because after, suppose we want to maintain a circular list. At that time, suppose this is the memory representation, we are storing the data item here, and what we usually do in a single linked list, we just write 0 in the pointer field of the last data item. But here the only difference between single linked list and circular linked list is, suppose the data items are A, B, C, so, and the position of, let me just write it here. If the first data item is 2 and the second data item is B, we'll write 4 here, after that 3, and in single linked list we can write 0, but in the circular linked list the value will be 1.
Two.
Sorry, 2. So this is circular linked list. Clear?
Yes, ma'am.
So I think this is the end of linked list. So far we have completed how many linear data structure, array and linked list. So in our next class we will start text and after that cube. Okay? So now we can do one thing. I'm just giving you a list, and then you have to just try to insert some data item, as well as I think you can delete the data item also. I'm just giving you a list and you have to insert and delete some data item from this doubly linked list. Okay? And suppose the list is not sorted, the data items are not sorted. So
Ma'am, they had a question.
yeah.
Which one should we use when? Like single, double, and circular?
Okay, you don't need to actually worry about it because it will be mentioned in the question paper that you have to use single linked list or doubly linked list or circular linked list. Okay, it depends on the requirements, what type of data you're storing, or which operation will be done frequently. It depends on those things. Okay, but
Alright, ma'am.
maximum time the thing will, I mean, it is actually meant. We always mention this thing in the question paper. That is, you have to use single linked list or double linked list or circular linked list. Okay, so this is an unsorted list. So the first data item is 43, and then 21. After that, 68, and then 38. So here, start equals to, or head equals to, which one is our first data item? 43, right? So head equals to 2. Here, head equals to 2. So the first data item is 43. After that, 21. After 21, it's 68. So it will be 4. And here the value will be 0. The last data item is 0.
আচ্ছা আচ্ছা ঠিক আছে যাও চল
Okay, so the previous data of 38 is 68. So 6. And before 68, we
আচ্ছা ঠিক
inserted
আছে রান্না করে
which
নিবা
data
যাও
item?
তাহলে
21. So it will be 1. And here the data will be 6. So this is the list. Now you have to insert some data item. Number 1, insert 74 at the beginning. Number 2, insert 12 at the end. Number 3, delete 38 from the list. Number 4, insert 9 between 21 and 68. Okay, so you have to add how many data items?
4
Hello, I hope you all are taking the notes.
yes,
This is your homework. Okay, just use the link and perform this 4 operation. At first, insert 74 at the beginning, and then insert 12 at the end. Delete 38 from the list and insert 9 between 21 and 68. I hope you can do it.
yes ma'am
Okay, you didn't ask me about the sequence of available spaces. But actually, you don't need it. There is only two available space, right? So you can make one the first available space. Suppose 3 is the first available space, so then 5 will be the next, right? And what about tail? Which data item is the last data item of the list? Here, avail equals to 3 and tail equals to
38.
tail equals to 4, right?
4, ma'am.
I hope you all have taken the notes. So can I clean the board?
Yes, ma'am.
What about the others?
Yes, ma'am. Taken.
Yeah, okay. So how many things actually we have discussed here in array and linked list? We know that we can perform 6 different types of operations on linear data structure. That is traversal, search, insertion, deletion, sorting, and merging. And on some array type data, we performed how many operations? 3 operations: insertion, deletion, and traversal. And for linked list, how many operations we did? Maybe 3. That is insertion, deletion, and searching. Right?
Yes, ma'am.
Yes, ma'am.
So now we'll perform the same operations on stack and queue. After that, we'll start searching operation. I mean, we'll use some searching algorithm for search operation. We'll use some sorting algorithm for sort operation. So do you have any question from today's discussion? Any question? No. Okay, so 1,